Alright, we're getting out of all of that Space Invaders stuff and going right back into a Midway 8080 set. This is Gunfight. And this one looks like it has a lot of soldering work on the back side of it. I don't know. I think it was just reflowing maybe. I don't know exactly. But it's got this big ugly socket in it. That's got to go. And this thing has 2532s in the board. It's got two 2532s, and I don't know if that's going to work or not. It looks like it's strapped for 2716s. So I kind of need to do a little research on Gunfight. What is the ROM set? Does it have 4 ROMs? 4 1K ROMs? What does Gunfight? How big is the ROM set in Gunfight? Because this just seems really strange to me to have two 2532s. That's 8K worth of ROM. And then this addressing scheme is completely different than a 2716. Well, a couple of the bits are different. So I don't see how this would work. I'm gonna do a little research. I might have to change the ROMs here. I don't know. So we'll look into all that. This has to go. This looks like it's been completely rebuilt. It does look like this connector needs to be reflowed a little bit on the back. And I might replace, I'll check this transistor, make sure it's good. And I might replace the old 12 and -5 volt regulators. And other than that, I'll put it in my game and I'll test it, I'll run it. It looks good. This needs to be washed for sure. Socket, I got to look into what's going on here. Why does this have 2532s? And yeah, that's it. Looks like this has all been recapped, which is nice. I don't have to mess with that. Looks beautiful. It looks really nice. And it's a nice looking board set. It's just this is a great big question mark. Because these 2532s have definitely a different scheme. Now, one thing that pops in my head is, are these chips that were bought from China? Because I've got some chips that I bought from China that are marked 2532 that are actually 2732s. So that's kind of something that I'm thinking about too. Are these actually 2732s? Because they look clean. They look like they might be newer, cleaner chips. I don't know. So we'll figure it all out. We'll figure everything out. It'll be all right. So, yeah. First things first, first things first, I'm going to do this. Let's get these regulators changed. I'm going to test this guy, resolder this, flow it up, put this in my Space Invaders game, and run it. That's first. Get this thing done and out of the way. And then we'll start with this. And the first thing I'm going to do is get rid of this socket. Alright, taking this thing apart, and I can see underneath this screw that connects the collector, there's a lot of green crusty corrosion underneath there. You see that? That's not good. So we're going to remove this transistor and clean this up. Get that corrosion off of there and retin that with some fresh good solder so that we can get a good connection on the collector there. Okay, yeah, checking this, I got some good sharp point. Very sharp. Okay. If I put this on here, okay. But if I come over here to where the circle where the screw connects for the collector, it's very hit or miss. You have to really dig in there. Yeah, it's just not a good connection. So I'm going to clean that up with some super fine grit sandpaper, and then I'm going to re-tin it with some fresh silver solder. I don't want to use leaded solder because I don't want it to. It'll stay cleaner, I believe, with just regular silver solder over the long haul. So that's what I'm going to do. Clean that up, and you can go from there. This all needs to be cleaned up. So yeah, let's do that. Okay, I got a couple things here. I got a 400 grit sandpaper, 400, and a Q-tip. Whoops. And some alcohol. I'm just gonna spray it a little bit and grab the Q-tip, kind of clean this as good as I can. That looks pretty good. Okay, now spray that one more time. And just really lightly clean this area. With your finger down on here, and we're just cleaning this. See that? That's getting a little bit better. And even closer, maybe still. Yeah, about like that, maybe. There we go. Let's try that. I mean, that looks a lot better, don't it? I'm going to try to tin that. See if we can get that tinned really good. And go from there. Okay, yeah, and here is the finished result. Nice and tinned. See that? Now we'll have no question about connection on the collector of that transistor. Next thing I need to do is actually test the transistor itself and make sure that it is okay. And then repopulate, put this thing back together. Alright. Yeah, I went ahead and re-soldered this, as it looked like it had quite a few cracked pins. And I went ahead and I resoldered the pots. All of the pots. And just for good measure on this guy, I went ahead and just soldered that screw because there was a lot of rust. I had just sanded that screw down because the screw itself was rusty. So I just sanded it down, and I soldered with silver solder, silver bearing solder, lead-free solder. I soldered right to it to make sure it's got a good connection. So from now on, this nut has to come off, or this screw will be kind of fixed, which whatever. It's better that way. And I replaced the two, I replaced the two regulators. And they have those silicone type pad heat sink insulators, so those they technically don't need paste. So I didn't put any paste down, but they're replaced. They're new. I cleaned everything up really good. So this thing's ready to just go in and be tested. So I'll throw this in my game and test it out. Okay. Here's the power supply. Alright, well, power supply is good. I'm just going to let this thing stay on for a few hours. And power supply is done. Okay, I got this board cleaned up, put back together. I put a new socket in it. And then just repopulated it, cleaned it up really good. I got it together, got the fluke on it right now, and I have done ROM checks. And basically what I did, these are looking like 2532s. I don't know exactly really what they are. I have verified these signatures, and what I mean by that is I ran a test from 0 to FFF. I wrote down what it told me, and then it verified against that. So it's not giving me random garbage every time. It is actually giving me this signature at this range. Now I need to find out, is this signature correct for this range? I need to put the Gunfight code together. Gunfight, I believe, is 4 ROMs. And someone has put together 4K files, you know, and put them in 2532. So I need to find out what's going on here. Is that actually correct, or, you know, type of deal? So I'll do that. And yeah, Gunfight. Gunfight might be a 4K ROM file. So are they using only the bottom of this? Are they only using... I don't know what they're doing here. I don't know. I got to figure it out. But if I do RAM checks, it's very beepy. So it's telling me 80. Right. 80. And if I loop that and I try jumping over the 8-bit, which would be, this is one of them. This is one of them. And then up here is one of them. And this is the other. And just, you have to just trust me. It doesn't make a difference. So I'm not sure that this is an actual RAM issue. This is a decoding issue. First thing I want to do is verify. Is our ROM okay? Is this right? That I don't know. So I'll figure that out first and foremost. Okay, so I did some preliminary poking around on this board. I know I said I was going to check the ROMs, and I'm going to do that. But I did some preliminary poking around. I don't see anything that screams issue. I tested all of the addressing out of the 157s, all of the 153s. I checked the signal coming out of this guy. What I hate is all of these RAMs have been either removed and replaced, resoldered. I think that they've been replaced, to be honest. I don't know for sure. It's just kind of, I know that they've been soldered. I think they may have been replaced. I don't know. I beeped them out and it's all good. The thing I'm wondering, are these RAM actually good? You know, I don't know. I don't understand if these were replaced, why they were not socketed. Is kind of where I'm at. Why would they be replaced and not socketed? So I'm thinking about removing all of these RAM and testing them. Because I'm not seeing anything that really looks bad. It's giving me random data errors. I can read the ROM. Over and over and over again. I looked at the signals of this clock driver chip, and it looks okay. I don't think that's an issue. I don't know. It's interesting. I don't know yet. Okay, this thing is telling me the odd addresses 08. These are the odd addresses. These are the even addresses. I'm pretty sure that's how it works. Evens and odds. And this is the least significant to the most significant bits. So here's 4 bits and then the next 4 bits. This one is telling me on the odd side it's 08, and it always says that. So, okay, this is the least significant nibble. So the most significant bit of the least significant nibble is this chip right here. This is the 8's position bit. This is the 1's position bit, right? So first nibble, second nibble. Most significant bit of the first nibble. On the odd addresses, okay? Odd addresses. Now if I do a RAM at, it gives me even, and it does this every single time, even addresses, and if I hit repeat, it's always even at 80. Okay? 80. So it's the most significant nibble, the most significant bit of the most significant nibble, which is this chip right here. So these are the two that it keeps telling me are an issue. So I'm going to go ahead and pull those 2 chips. Okay. I have removed those 2 RAMs out of right here and right there. Okay. Now let's go RAM short 24. Alright, yeah, my Fluke 8080 pod failed on the RAM test from 2400 to 3 FFF. I don't know, it does that. But you can do, if you do each individual range, like if I go 24 of the video RAM to the next 1K of video RAM, which is oops, 27 FF. That tests 1K of video RAM. And it does that top part of the screen there. If I just go through and do each 1K block individually, it works fine. This is just how my 8080 pod works. I don't know. Yeah. But anyway, yeah. Run UUT and Gunfight. All right, actually, I think it failed for a reason. If we come over here and look, we got some goofiness down here on the bottom of the screen. See that? That's not supposed to be there. And this, how this screen works, the top of the video RAM is way up here. 2400 to 3FF. And it's like 8 kilobyte block. So this bottom block is where it has an issue. This is 3C00 to 3FFF. So if I go ahead and I do a short test and just omit that range, and let's go 24 to 2 or to 3C00 or 3, how about 3BFF? 3BFF. Okay, yeah, and it'll go all the way down to right here and it'll stop. It's finishing up. I'm sure of it. Any day now. Okay, there we go. See, that passes. Now if we do that last portion, come over here, let's test this last portion right here from 3C00 to 3FFF. And when it gets down here, it's going to fail because there's a bad bit right there. And we can tell where it is, what the fluke tells us. Remember, this is even addresses, this is odd addresses. So if we now do a short from 3C00 to 3FFF, it'll get down there and it will, oh, it already beeped. See? It already beeped and it's telling us on the even side, the most significant nibble, the 2-bit. On the even side, even address, see, 3F80, the most significant nibble, bit 2. So that would be the evens right here. The most significant nibble is these 4 bits. Bit 2 is right here. This is the RAM that's bad right here. So the third one down. So I'll replace that guy and we'll rerun the test. And how I did that now. This is the even addresses right here. of the 8 bits, the most significant is right here. So this is the most significant nibble. Nibble is 4 bits. The 2, it's telling us, the fluke is telling us 2. Well, if you write out in binary the 1 bit, 2 bit, 4 bit, 8 bit. So it's telling us the 2's bit is bad. That is the 1 bit, 2 bit, 4 bit, 8 bit. So this guy right here is no good. Okay, another RAM replaced. And we're all cleaned up. Okay, go ahead and put the fluke back on it and make sure that we're passing the RAM checks as we should now. Okay, we're all hooked up. And I started running that RAM check. And it gave me another error. This time on the odd side, the same chip on the odd address side. This one right here. That's another one that's got to be replaced. Goodness gracious. So I'll have to replace this guy. Okay, RAM number 4 replaced. Alright, well, I fired it up, started running that RAM test again on that bottom part, and it gave me another error. Odd side, this time the 2-bit on the lowest, the low nibble, which I wonder if that was the same way the last time and I just read it wrong. I'm going to have to look back at my video and see if I removed this instead of needing to remove this. We'll find out. Nope, I just looked at the video and it did indeed say that this chip was bad the last time. This time it's telling me this one. The lower nibble, the 2-bit. So, yeah, this guy. So I got to replace that one now. Another one changed. It's looking good. There you go. Run UUT. This baby had 5 bad RAMs. 5. And there we go. Now it looks right. No more nonsense down here. Gunfight. Okay, next thing to do is hook up the rest of my harness, test all the sounds and all that good stuff. Alright, we're ready to do some testing. I went and I got this is the pin out right here for this. So we'll go ahead and get the tripod out, hook it up, point it at this, and I'll very feebly mess around with controls. Okay, see if we can do this. Alright, coin and start. Alright, let's move the left guy up. Alright, left guy down, 17. Left guy right, 6. Left guy left. Alright, let's do left guy gun position 1. Okay, that pointed it down. Now 11 is gun position 2. There we go. In gun position 3. There we go. And fire. Left trigger. And right trigger. Okay. Looks like the counter is counting correctly. Okay, now we'll do the right hand side guy. Right move up. Right move down. Right move left. And right move right. Right, gun position 1, which will be down. Position 2. Position 3. There we go. And we already heard the trigger. And I don't know if I can shoot anybody. Let's move him to the left. 12. Down 17. Down is 9. Let's start over. Okay, let's do this. Let's try to anyway. Right gun 12. Let's move everyone down. 17 and 18 and okay. Let's move the right guy up. Yeah, that's it. There you go. All of the controls are good. The sounds are good. I'm just taking this grounded lead and touching on the edge connector. So this thing had five bad RAM. And it was kind of a tricky one because these RAMs weren't bad in all of the address locations. It's just certain locations within the chip had bad cells. On all of them. It wasn't like any of these were just flat out dead. Yeah, very strange. Would be extremely hard to do this without the fluke. Without the fluke, this one would have been very challenging. I never messed with these. I just figured they were correct. So, yeah, they are correct. I never checked those at all. So, this was all RAM. And, yeah, like I say, without the fluke, this one would have been very tough to diagnose. Because these RAMs were just very strange. They weren't just blown out dead. Yeah, so... interesting. They all had higher range, bad cells up in the upper address range, their upper address ranges, I guess. All right, that's going to do it for this one. Another gunfight, ready for the cabinet, ready for some fun. All right, guys, thanks for watching. Once again, as I always mention in my videos, thanks for everyone who is channel member or subscribed on Patreon, helping me help and support, curate, keeping these great old vintage machines going. I do appreciate it. Until next time, we'll see you on the next Classic Arcade Repair. Bye for now. By the way, I just noticed that I left this thing on all day for 48 hours. When did I turn this on? I did not come out here yesterday. So it was 2 days ago this thing's been running. Goodness gracious. I ran this thing for 2 days. Well, I guess the power supply is good. Goodness. Yeah. That's a good 2-day run test for that. All right. This one's going to run for 3 hours. Hopefully I remember to turn it off. We'll see you next time.